Today we're going to look at area. What is it and how do we calculate it? So area is the surface measurement of two-dimensional shapes. We can think of it as square units that a shape covers. So everything has an area. If you look at your desk and the top of it where you put your paper and your pencil, the top of that desk, the surface of it has an area. It takes up a certain amount of space. The walls also have area, and we can calculate that. If you look at the tile floors in each of the classrooms, each of those tiles is 12 inches by 12 inches. So that makes them have an area of 1 square foot. You can actually calculate the area of the tiles in each classroom by counting up the number of tiles on the floor. Of course, counting tiles would not be very efficient, and not every floor has tiles. Just think about the floors in your house. Some floors might have tile, others might have wood. Some might be covered in carpet. Our classrooms have both tiles and carpet, so we can't just rely on counting tiles. There's another way to do this to calculate the area of rectangular shapes and parallelograms, and that's with the use of a formula. So the formula we're going to use is A, and the A is capital for area, and we're going to multiply it by the base times the height. Sometimes you'll also see it as area equals length times width. Notice how the dimensions, the base and the height, and the length and the width, they have lowercase letters. Okay, so B for us, when you see B, we're talking about the length of something. We're talking about the length of the base, and H is the height of the rectangle, or also the width of the rectangle. And then area is measured in square units. So just go back and think about those tiles. That's what we're talking about. The area is measured in square units. So some examples, right? If we're measuring something in inches, we would say inches squared. We'll use that as our label for the area. If it's feet, it's feet squared. If we're doing meters, right, the base and the length or the base and the height are measured in meters, then it would be meters squared. Let's look at some actual examples here on the paper now. So rectangle number 1, we can see that we have the square units inside. Each one of those squares is called a square unit. We don't know what it's measured in. Is it centimeters, inches, feet, so on? So because we don't have an actual unit of measurement, we're just going to say square units. Now we're going to calculate the area of that rectangle by counting up all of the rectangles. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. So we know that the area of this is 35 square units. Now, obviously, that's very cumbersome. It's not very efficient to count all that up. Just imagine a warehouse, like an Amazon warehouse. I mean, that could be tens of thousands of square units. You wouldn't want to count those up. It'd be ridiculous. So that's where the formula comes in. And we can simply calculate it by counting the length of each side, or multiplying the base of each side times its height. Now, we don't need actual numbers to calculate the base and the height if it's already broken down into square units for us. So we can see that there's 1, 2, 3, 4, 5, 6, 7. So we're going to say here that the base is 7 units. And the height is 1, 2, 3, 4, 5. Now, it might seem a little counterintuitive that I've used the bottom side as the height and the base as that left side going upwards. But because we said that the base equals the length of an object, length is always the longest side. So if I was to rotate that rectangle around so that longest side was on the bottom, then that would be our base there. So length is always the longest side. Just keep that in mind. So using the formula, area equals base times height, we can then just substitute the values. So the area equals 7 times 5, which means the area equals 35 square units. We can write it like this. Let me zoom in on that. Okay, so let's look at rectangle 2 and calculate the area for that. You can see this is a bigger rectangle than in rectangle 1. We're not going to do something silly like count up all of the squares though. Instead, we'll use our formula of area equals base times height. And what we'll do is instead of counting all of the individual squares, we'll just count how many units the base and the height are. So if I count across here, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 units. So I'm just going to say this is 9 units. That's my base. And then my height is 1, 2, 3, 4, 5, 6. So we'll say H equals 6 units. And then we can use our area formula. So we'll plug in the values. A equals 9 times 6. So the area is 54 units squared. Okay, so on rectangle number 3, we have a much smaller rectangle. We'll go ahead, we'll write down our formula. Area equals base times height. And we'll count up the units for each dimension for the base and the height. So we've got 1, 2, 3, 4. So 4 units here. And 4 units on this dimension, on the height. So if we go ahead and plug in the values, again, it's going to be 4 times 4. So 4 squared is 16 units squared. Pretty easy. So let's go ahead and look at some examples now where we don't have the square units in the diagram that we're looking at. In problem number 1, we have a rectangle that has 2 measurements already on there for us. They're labeled. Remember, the longest side is going to be the base. So up on the top here, we have a base that is 8.6 centimeters long. And the other dimension is our height, which is 3 centimeters. So we've got our measurements. And even though there are no square units displayed on the diagram, we can still figure this out by using our formula. So area equals base times height. We'll go ahead and substitute B and H with 8.6 and 3. And then we'll multiply those together to calculate the area. So 8.6 times 3. 6 times 3 is 18. 8 times 3, is 24 plus 1 is 25, and move my decimal over 1. So I have an area that is 25.8, but now look, we have a label. We know that that rectangle is measured in centimeters, so our label is going to be centimeters squared. So by now I think you guys have the hang of this and what we need to do. So I'll let you guys have a couple minutes to do this. We'll pause the video so you can make the calculations. And then when we unpause it, after you've had a few minutes to work on it, we'll check the answers. So go ahead, try this out. I'll give you a hint though. When you're multiplying mixed numbers, you want to change those mixed numbers to improper fractions first. All right, go ahead. You guys try it now on your own. Okay, so here's the answer. We should have an area of 3 3/8 feet squared. The first thing I did was I identified my dimensions. So I found the base and the height. I then changed the mixed numbers to improper fractions. So 2 1/4 was 9/4. 1 1/2 is 3/2. And then I went ahead and multiplied them together. And my improper fraction, the product of 9/4 times 3/2 was 27/8, which as a mixed number is 3 3/8. All right, let's look at how we can use the formula to help us find a missing dimension. So what happens if we know the area of a shape and we know the base, but we're missing the height? Or what about if we have the height and the area, but we're missing the base? We can rearrange our formula to help us with that and then find that missing dimension. So these are called one-step equations, and we haven't done those before, but we'll have a preview of them now. So one-step equations. We can use our formula in this one-step equation to help us find it. So if we're looking for the base, but we know the area and the height, we can find the base by taking the area and dividing it by the height. If we're missing the height, but we know the base and the area, we can divide the area by the base. These will make more sense on the next problem. So let's have a look at that next problem. It's problem number 3. You can see here the area of the rectangle is 162 meters squared. So there's 162 square units covering the surface area of that shape. You can see here we have one of the sides. In this one we have what looks like the height, and we're missing the base, right? B is unknown. Well, we know using our formula of area equals base times height that we can plug in the values. So in this one, we know the area is 162. We do not know the base though. And the height is 18. So something times 18 is 162, right? B times 18, so some number that we don't know, multiplied 18 times, is 162. Well, we can find out what that number is by dividing. So on the side here, I'm going to divide 162 by 18 to figure out what the base is. So 162 divided by 18 would be 9. So the value of B is 9 meters. We can go ahead and double check that. 18 times 9 is 72. 9 times 1 is 9, plus 7 is 16. So there we go. See, 18 times 9 is 162. So my formula was area equals base times height. I plugged in the values, and I realized I had to figure out what I would multiply 18 by to get a product of 162. So I went ahead and divided them, and I got my value. In the next question, we're asked to circle all of the formulas below that could be used to find the height of a rectangle with a base of 11 inches and an area of 120 inches squared. So I'm just going to go through and underline my important information. So I'm finding the height. The height is something we don't know. The base is 11 inches, and the area is 120 inches squared. So if I use my formula of area equals base times height, and I plug in the values, I end up with 120 equals 11 times h. So do I see one of those answers on there matching up with this? So it wouldn't be A, it's not B, but here you see we have C, 120 equals 11h. So that is an answer. We still have to check to see if there's other options. Now we know that 11 times something is 120. And in the previous problem, we divided the area by the base. So in this one, we could divide 120 by 11 to calculate our height. We can see here that D is another option. So our answers to this are C and D. Okay, so let's turn to the last page of our packet. You'll see at the top left, it's called Homework 1. And what I'd like you to do, if there's time in class, is try problems 1, 4, and 5. And then check your answers to see if they're correct. If you don't get to finish this in class, it is homework tonight.